Imagine stepping into a spaceship, traveling near the speed of light, and returning to Earth to find that while only a few years passed for you, decades or even centuries have gone by for everyone else. This isn't science fiction. It's the strange and real phenomenon of time dilation, one of the most mind-bending concepts in Einstein's theory of relativity. So how does traveling fast slow down time? And could it actually make you younger? To understand time dilation, let's start with Einstein's special theory of relativity, published in 1905. One of its core ideas is that time is not absolute, it's relative. This means that how fast time passes depends on your frame of reference. If you're standing still, time flows normally. But if you're moving extremely fast, near the speed of light, time for you slows down relative to someone who's stationary. Think of it as a cosmic time machine. Your clock runs slower compared to others. But how do we know this is true? One of the most famous experiments proving time dilation involved atomic clocks. In 1971, two scientists, Haffel and Keating, took atomic clocks on airplanes flying in opposite directions around the Earth. When they compared the clocks to ones left on the ground, the airborne clocks showed that less time had passed. This experiment confirmed Einstein's prediction: the faster you move, the slower time passes for you. So how does this work? It all comes down to the relationship between space and time. According to Einstein, space and time are interconnected, forming a single fabric called space-time. When you move through space, you distort this fabric, which in turn affects how you experience time. At everyday speeds, this effect is so small that we don't notice it. But as you approach the speed of light, 300,000 kilometers per second, the effect becomes dramatic. At 90% of the speed of light, time passes about half as fast for you compared to someone on Earth. At 99.9%, time nearly stops. Now you might wonder, could traveling fast really make you younger? In a way, yes. If you spent 10 years traveling near the speed of light and returned to Earth, much more time would have passed here, maybe hundreds of years. You'd be biologically younger than everyone else who stayed behind. This is often called the twin paradox. Imagine two twins. One stays on Earth and the other travels through space at near light speed. When the traveling twin returns, they're significantly younger than their sibling. While this might seem counterintuitive, it's been verified by experiments and remains one of the most fascinating implications of relativity. But time dilation isn't just a theoretical curiosity, it has practical applications. For example, GPS satellites rely on time dilation corrections to function properly. These satellites orbit Earth at high speeds and experience time slightly differently than we do on the ground. Without adjusting for this effect, GPS systems would lose accuracy, throwing navigation off by kilometers. It's a reminder that Einstein's theories don't just live in textbooks, they're essential to modern technology. Time dilation also has implications for space exploration. If humanity ever develops spacecraft capable of near light-speed travel, astronauts could use time dilation to journey to distant stars within their lifetimes. However, when they return, centuries or even millennia might have passed on Earth. This raises fascinating questions. How would these travelers adapt to a world so vastly different from the one they left? Would they still recognize anything, or would they be strangers in their own future? But there's a catch. Traveling at near light speeds requires an enormous amount of energy. According to Einstein's famous equation, E mc2, the energy needed to accelerate an object increases exponentially as it approaches the speed of light. For now, the energy demands make such travel impossible. But advancements in technology, like antimatter propulsion or warp drives, might one day bring us closer to achieving this incredible feat. Time dilation also forces us to think differently about our understanding of time itself. We often think of time as a constant, ticking forward at a steady pace. But Einstein showed us that time is flexible, malleable, and deeply tied to motion and gravity. In fact, gravitational time dilation, caused by intense gravitational fields like those near black holes, can also slow time. Imagine standing near a black hole's event horizon. Time for you would crawl, while the rest of the universe races forward. This idea inspired the plot of movies like Interstellar, where time dilation plays a central role. As we wrap up, time dilation isn't just a concept for physicists, it's a window into the nature of the universe. It challenges our perception of time and offers glimpses of what might be possible in the future. From atomic clocks to space travel, the implications are both profound and practical. Who knows? Perhaps one day, understanding time dilation will unlock the secrets of aging, or even immortality. If you found this exploration of time dilation fascinating, make sure to subscribe for more deep dives into the mysteries of science and the universe. And let us know in the comments, would you take a journey near the speed of light, even if it meant returning to an unrecognizable Earth? We'd love to hear your thoughts.